This is the second part of Unit 5. It's Lesson 2, dealing with mini-proofs. These mini-proofs are going to get your brain kind of re-wrapped around what proofs are. Recall that proofs are a sequence of justified conclusions used to prove the validity of a statement. Each step of an argument is justified with a valid reason. We used algebraic proofs to step-by-step go through how to get x by itself. We're going to be doing proofs that require a bit more geometry than the ones before. Two-column proofs are called two columns because they have two columns. The column to the left is the statements. These are the things that you know, and reasons are things that you need to show. So what goes in the statement column? Things that go in the statement column are congruent segments. So you saying that segment AB is congruent to segment BD. These are congruent angles. Angle 2 is congruent to angle 3. Lines are parallel. Things that you observe. And then what goes in the reason are really the reasons why. So if you tell me that two segments are congruent, well, why are they congruent? Two angles are congruent, well, why are they congruent? Sometimes your reasons are as simple as given. Reflexive property. If you conclude that two triangles are congruent, well, then you have to tell me why are they congruent. Angle, side, side. All of the theorems, postulates, properties that we've learned throughout geometry are pretty much open for use. Bottom line, proofs are an organized way to make conclusions based on geometry facts. So again, the purpose of these mini proofs is to reintroduce you to proofs and review prior terms and definitions. These in general have very few steps. I think the most that any of them have is 3. They're meant to be very small, hence the word mini proofs. First one says, given segment AD bisects angle CAB. My first statement is going to be the given. AD bisects angle CAB. How do we know that? Because it was given, it was stated. After you write something in a statement and you give its reason, you mark it. CAB, so it's up here. I want to conclude that angle CAD, so this one, is congruent to BAD. It's a mini proof, so we already have it marked. But what is the reason that those two angles are congruent? Look back at the statement you gave. You used the word bisect. Because of the word bisect, you knew to mark those two angles congruent. So you can go as basic as definition of angle bisect. Or you can give an if-then statement. They're a little bit harder to word. We've worked on them before. If, and these need to be generic, if a segment bisects an angle, then the angle is cut into two congruent angles. Second one, you're given that two line segments are perpendicular. AD is perpendicular to BC. It was given. Perpendicular leads to what? Perpendicular leads to right angles. By definition, we now know that angle ADB and angle ADC are right angles. So you can use definition of perpendicular. If you want, you can write an if-then statement. If two line segments are perpendicular, then right angles are formed. This particular proof, and it's going to be the longest one and maybe the hardest, is asking you to prove that the two angles are congruent. Well, we know that two angles that both equal 90 degrees have to be equal to each other. So if two angles have the same measure, which they do because they're both right angles, then the angles are congruent. Letter C is dealing with parallel lines. Line segment DE is parallel to line segment BC. Because it's given, I'm going to mark it. DE is parallel to BC. We spent much of Unit 3 dealing with parallel lines, and usually when we had parallel lines, if lines were parallel, then there was a certain angle relationship. So that kind of angles are, and we filled it in with either supplementary or congruent. So the types of angles we had same side interior, same side exterior, alternate interior, alternate exterior. We had corresponding. So if lines are parallel, then these particular angles are supplementary. And if lines are parallel, then these particular angles ended up being congruent. So what angles are we dealing with? It says prove angle ADE to be congruent to angle ABC. So ABE ADE is this one here. ABC is this one here. Here and here. They're in the same position on two different lines, so these angles are corresponding. If lines are parallel, then corresponding angles are congruent. 2 steps. Letter D. It says that D is the midpoint of BC. What I've done is I left the proof blank. What do you think you're trying to prove? If D is the midpoint of this line segment BC, then what do you know to be congruent? Well, we know that DB is congruent to CD. That's what it is I'm trying to prove. Mini proofs are mini because there's not many steps. If you can get that far, then it's just a matter of putting it into words. First thing, D is the midpoint. Well, it was given to me. We know that because D is the midpoint, that these two segments are congruent. So your definition or your reasoning can be definition of midpoint. If you want to write an if-then statement, you can say something along the lines of, if a point is the midpoint of a segment, then the segment is divided into 2 congruent pieces. This is letter E. There's no given and there's no proof. There's no given because nothing is actually given to you. What's the only thing you could assume from this diagram? We've talked about this particular one multiple times. We know that the only thing, there's no sides, there's no angles, there's no parallel. It looks perpendicular, we don't know. It looks like angle A is being cut, but we don't know. It's not specified. The only thing that we can assume is that AD is being shared. So this proof is really just being split into 2 columns so that you can write your if-then statement. So the only thing that we can state that is true in this diagram is that AD is congruent to AD, and your reason can be the reflexive property. If you want to write an if-then statement, if 2 triangles share the same side, then the triangles are congruent. You will have homework. We'll get to that eventually. Here are some definitions that you will need when we get to the homework, one of which is altitude. Altitude is a perpendicular segment dropped from the vertex to the opposite side. Median is a segment that has its endpoints at the vertex and the midpoint of the opposite side. Basically, median is splitting the bottom into two congruent pieces, but it's not necessarily perpendicular. Look at that, it's not 90 degrees. Altitude, on the other hand, is only making something 90 degrees. It is not saying that those two lengths are equal. Visually, they're not. One last comment that I want to make. It says in each diagram, the red, which I have in a box, like a dotted, and the blue, which I have as a solid, are congruent. Identify their common side or angle. Looking at these pieces, basically I want to see where do things overlap. So in triangle 1, we have the blue, which is here, and we have the red. What do they have in common? They actually have angle M in common. Reason behind that would be the reflexive property. Number 2 here, we should be able to see that DF they have in common because, again, of the reflexive property. And then in number 3, kind of a twist still, we have two triangles. There's one on top and there's one on bottom. And if they're slid on top of each other, if I drew it right, these two side links here are really the same. The purpose of this slide, sorry, that's kind of a mess, is to show you that the reflexive property doesn't necessarily come always when two triangles are sitting side by side nicely. 2 is sitting side by side, 3 are actually on top of each other, and in problem 1, the angles are shared. So essentially, reflexive property is when a part is equal to itself. So if you were to separate the triangles in number 1, draw these crazy, angle M's at the bottom, and angle M is still at the bottom. So K, N, M is this triangle, and P, M, L is the triangle over here, so they both share angle M. And that concludes lesson 5 of Unit 5.